So we have previously talked a little bit in Chapter 4 about moments, how to calculate the moment of a force. We've even dealt with calculating the moment of force about a specified axis. Today we're going to talk about moments of a couple. So what we mean by a couple is two forces, equal magnitude, opposite direction, right? So what we're going to do, in effect, is we're going to calculate the moment of one of those forces about a point, and then add to it the moment of the other force around the same point. And we're going to find out mathematically what that sum is equivalent to, and we're going to see something rather interesting when we do that. So let's get started. So let's imagine that I have a force that goes in this direction, and I have over here a force that goes in the opposite direction. They both have magnitudes of F, okay? So here's F going off in this direction, here's F going off in that direction, and basically it's negative F, right? It goes in the opposite direction. So let's pick some point down here, let's call it O. And then let's draw a position vector that goes from O to F. Let's call that position vector RA. And so we can calculate that the moment of the minus force, right? It's the minus force is equal to RA cross that force, minus F. We can also draw a vector that points from, let's do it this way. So here's the line of action of the force, which I just missed, but it should point to that line. I'll call it RB. Right? And we can say, well, the moment that's created by the F force, both of these about point O, is equal to RB cross F. So let's calculate the sum of the moments that are about point O. The sum of the moments means I need to add those two together, right? So we have RB cross F plus RA cross F, and it's a minus F. And this sign, of course, is just a magnitude that we can kind of move around. So we can rewrite that as RB cross F minus RA cross F. All I did was I moved this minus sign from the F to the RA. I have now two things crossed onto F. Right? So using the distributive rules, we have RB minus RA cross F, right? So let's talk about this RB minus RA. What does that mean? If I have a vector RB and I subtract from it RA, what am I describing there? What am I describing? So here's my vector RB and I subtract from it RA. That is providing this information, right? It's telling me how to get from that point to another point. Okay? RB minus RA. RB minus RA is telling me how to do this right here, which we'll call R. So note that this vector R points from the force that we identified negative towards the force that we identified as positive. And once we see that, we see that the sum of moments is nothing more than R cross F. The other thing we'll notice is when I've written it in this form, right? And I think about the fact that RA could have pointed from anywhere are pointed from O to anywhere on this line of action, right? So RA could have pointed from O to anywhere on this line of action, and RB could have pointed from O to anywhere on this line of action. Remember, that's all the requirement up here for RA and RB, is it points from 0 or point 0 or point O to anywhere on this line of action or anywhere of this line of action. That means had I chosen, say, another point for RA to point to and a different point for RB to point to, then I just would have gotten a different R, right? So in this formulation, right, this R right here only has to point from the line of action of one of the forces to the line of action of the other force, and the force that it's pointing to is the one that we write in Cartesian notation and use here. Okay, that's point number 1. Point number 2 is that I could have selected a different point for point O. So let's say I chose this as point O, and I said, hey, this is RA, and this right here is RB. And I had done exactly what I had done before, I would get exactly the same equation. Exactly the same equation. What that means is that this little subscript O is not necessary. When I have a couple, when I have two forces equal in magnitude, opposite direction, and I want to calculate the moment, that moment is just equal to a vector that points from one to the other crossed with that force vector, and there's no subscript. It's the same no matter what point I calculate that around. That means that this is a free vector. Okay? What that means is that the torque, or the twist that I apply by using this couple, is the same no matter where I calculate that twist. And that's what we mean by moment of a couple. So a couple of points, it's rather easy to calculate. You just have to find some vector R that points from one of the lines of action to the other, and then you write the other, the one that the head of R points to or touches, as Cartesian notation, and then you can carry out the cross product very straightforwardly. We'll talk more about this and work some examples in class. Thank you.